Hi everyone, this is AYUSH Umang. I am selected as a scientific officer in BARC through GATE. In GATE, I got All India rank 45 in mechanical engineering paper in my final year of BTech. In third year also I gave GATE and there I got All India rank 134. So that's all about myself. In this video, I will be sharing my experience of BARC interview which took place on 7th of June in Mumbai. So let's start. So in my interview, it went somewhere around 1 hour and 20 minutes. And talking about the BARC interview, it is, you can say, one of the difficult technical interview in India. It consists of basically they grills you for about an hour and they will judge you based on your technicals only. There will not be any HR question as such as what happens in other PSUs. So basically they will judge you on your technical only and your concepts only. So let's start. So first they will ask you to sit in a chair in front of the panelist, and there they will ask few questions about yourself, 5 to 6 minutes just to calm you down, so that you don't have any nervousness, and they get a clear picture of your understanding of concepts. So basically for the first 5 minutes, they asked me about myself, where I am from. I told I'm from Jharkhand. So they asked what is Jharkhand famous for, and I answered that there are a lot of coal mines in Jharkhand and a lot of minerals are available in Jharkhand. And then they asked questions on what major power plants are there in Jharkhand and what is the total capacity of all the power plants in Jharkhand. I told them few names of the power plants in Jharkhand, and I could not answer the total capacity of all the power plants. So then they asked, there is power shortage in Jharkhand. What could be the possible reason behind it? And I answered that there are some political reasons behind this and all that, but they were not satisfied. After that, they asked me about my GATE score. I scored it in final year. They talked about that for few minutes, and then they asked me about my college placements. I got placed into Hindalco Industries, and they asked what package does it offer, what is the place of posting, and all of that. Then they asked me, "Do you know about BARC interview?" And I answered them yes. Then they asked, "What happens in BARC interview?" And I explained them for a few minutes. Then they asked me any two favorite subject, and I told them heat transfer and thermo. But after that, they said that we are not going to ask questions from these two subjects only. We are going to ask questions from each and every subject of BTech. Are you comfortable? I said yes, sir. Then they um, asked me to go to the blackboard, and my technical interview then started. So the one panelist then asked me that they suppose there is a 1,000 megawatt capacity power plant in Jharkhand, and you need to calculate coal requirement on per day basis. You can assume parameters and other informations accordingly. And then I approached the problem talking about various efficiencies in power plants, and I took few assumptions, like I took overall efficiencies at 30%, heat transfer efficiency of boiler at 80%, and I did not knew the calorific value of coal, so I assumed the value to be CF. I asked them that, sir, I don't know the calorific value of coal. Then they told me that you can assume any variable. After that, um, we had few conversation about overall efficiency of plant, why you have taken 30%, why not 70%, 50%, or 10%. And then he asked me to compare it with the IC engine efficiency. What is the efficiency of an IC engine? Why the efficiency of power plant is more than IC engine? And after that, they asked me to explain boiler efficiency. What is boiler efficiency? You have taken boiler efficiency in your calculations. And after that, I use these formulas: heat input to steam in boiler, this is our power output. I divided by overall efficiency to get heat input to the steam, and after that I divided it by the boiler efficiency to get the heat produced by burning of coal, and the value of Q we got was in megawatt. So I converted it into per day basis by multiplying it with 60 seconds, then 60 minutes, and 24 hours, divided by calorific value of coal to get per day coal requirement. And after that they asked me, you have not taken mass flow rate of steam in your calculation, don't you need that, just to confuse me. And I told them that sir, mass flow rate is not required in calculation, because our calculation is already based on time basis on per second, and here I just need to convert it into per day basis. Then they asked me how you can increase the overall efficiency of plant. In this I talked about the mean temperature of heat addition, regeneration, reheat, and they asked few questions and cross questions in these two, and asked me to draw a TS diagram and explain all the three topics in TS diagram. Mm, yeah, then they asked me how would you calculate mean temperature of heat addition in plants. I answered them that we need entropy at the entry of turbine and at the exit of pump. So using that we can calculate mean temperature of heat addition. He then asked that you don't take steam table or Molar chart in plant, any other method to calculate entropy. This question I was not able to answer, because we have studied to calculate entropy using steam table and Molar chart only. So I answered them clearly, sir, that I don't know any other method of calculating entropy. Then they asked me about the operating temperature range of boiler and IC engine. I told them. Then few discussions went on theoretical limit to overall efficiency. Why not it is 50, 60, 70, 80%. Talked about Carnot cycle, how the upper limit to efficiencies is fixed by second law of thermodynamics. Then they asked question on condenser. Why do it is necessary in power plant? Can we remove it or not? Told them. Then the operating pressure of condenser and why it is lower than atmospheric pressure. Why not higher or equal? After that, another panelist asked me to draw a piston cylinder arrangement containing air, and he said that 10 kg of weight is put on it suddenly, and asked me to draw this process on PV diagram. So because the weight is put suddenly, so it is an adiabatic process, and I drawn adiabatic process 1 2 as shown in the figure here. He then asked what is adiabatic, why it is adiabatic, explained them. Yeah, and another member told me to leave it for a long time after putting the weight. Now draw the process. So after that, I told them that because if we leave it for say infinite time, that in that case heat will start flowing out of it, uh, and this would be constant pressure process, constant pressure heat rejection. So this would be the process. And then he asked how would you point out this point 3. Then I told them that we can point out point 3 by drawing an isothermal line from 1, because the dead state, which is reached after the gas is in equilibrium with the surrounding, is with that temperature in which in which it was initially, right, explained. Now they asked me to replace air with helium and draw the process again. I answered them this process would be the same, but the slope of this line would get shifted like this, because the adiabatic index gamma of helium is greater than that of air, that is 1.67 as compared to 1.4 of air. So this would look like this, and they looked satisfied. After that, another member asked me to draw a dam with curved gate at bottom like a quadrant of a cylinder, and asked me to calculate forces on it. I drew something like this, and he asked me to draw forces, to ask me to calculate forces on this curved plate. I explained them that this would be the vertical, this would be the horizontal force acting on this curved force would be equal to pressure at the CG multiplied by the projected area, this projected area, and the vertical force would be the weight of water carrying by this part of water. And after that, they asked me to close the dam from the top and put pressurized air at the top of the free surface and then calculate the forces. Then I explained him that we can imagine it to be a water at this level, where this height would be equal to the head of pressure of air. And after that, they asked me to remove water and put air completely inside the tank, and now calculate the horizontal and vertical forces. So in that case, I got confused for some time, but then I approached the problem, and I told them that the vertical force would be the same imaginary upper, but that was the wrong answer. After thinking for a few minutes, I came to conclusion that the density of air is very small. Because of that, the gradient of pressure in depth direction would be negligible. So because of that, if we are to calculate force on this curved surface, we just need to calculate the pressure, that is the pressure, and multiply it with the area of this curved surface, would simply give you the forces, overall resultant forces. And if we multiply it with cos 45 degree, that is divided by root 2, then we will get the horizontal force, and the same would be the vertical force. Yeah, so then he asked me, why didn't you use the same approach as that of water to calculate vertical forces, weight carrying out by this curved forces? I explained them with this formula of hydrostatic equation, that the rho is very less, so the pressure gradient is very less, so we don't need to do that. We just need to multiply the pressure with the area of this curved surface, that would give the resultant force. And if we would break it into horizontal and vertical component, we get vertical and horizontal forces. So then another question that was asked to me was from heat transfer. They asked me to draw a cylindrical rod whose ends are maintained at 300 degrees Celsius and is diabatic, that is heat transfer is allowed on the end surfaces, and the lateral surfaces is insulated. The ambient is at 30 degrees Celsius, and they asked me to draw the temperature profile axially. So I draw something like this, because if this is at 300 degrees Celsius and it is in steady state, then there must be heat generation inside this rod, and because of that, the temperature would be maximum in the middle, and it would decrease gradually as we move outwards. So the temperature profile would look something like this, with maximum at the middle point because of symmetry condition. Then they asked me that why maximum at this point. I explained them that at this point heat transfer is from this side and this side, and that would be equal. Because of that, the net heat transfer in this part is 0. So because of that, the slope had to be 0 there, and because of symmetry conditions also, the left and right hand side should look symmetric, and the slope would increase gradually. Then they asked, why not this? why your slope is decreasing, why increasing, sorry, why not decreasing like this. Then I answered that the heat transfer rate would increase as we move outwards from this middle point. So because heat transfer increases, so the temperature gradient should also increase, that is the slope should also increase with maximum at this point. Hmm. Then they asked me to remove the insulation, this insulation, and now the heat transfer is allowed from all the sides of the cylinder, and they asked me to draw the temperature profile in that case. I tried to approach the problem, did few manipulations, but I did not had much confidence in that answer. I drew something like I believe this, but I was not sure, and I told them that I'm not sure. And they said that all right, no. Then another panelist was there, and they asked me last question from strength of materials using the same bar. They asked me to put two rigid walls on the sides of the same bar, which is maintained at 300 degrees Celsius, and asked me to calculate what would be stress in that case. I told them if the bar is initially maintained at 300 degrees Celsius from both the sides, and then it is put in between the walls, then there would be no stress, zero stress would be there. But then they asked if the bar is heated after putting the walls, means the walls are first put and after that the bar is heated to 300 degrees Celsius from 30 degrees Celsius, then what would be stress in that case. I told them that in that case thermal stress would be induced, that would be compressive in nature. In the first case, we first heat it to 300 degrees Celsius and then put it in between two walls. In the second case, we first take a bar at 30 degrees Celsius, fix it in between two rigid walls, and then heat it to 300 degrees Celsius. In the first case, stress would be zero. In the second case, it would be a finite value. So after that, they asked me that if one side is maintained at 300 degrees Celsius and other is maintained at 600 degrees Celsius, then draw the temperature, then draw the stress profile. And I draw something like this. They asked why linear, why increasing, why not constant. Answered. Then they asked me to derive this mathematically, and I derived it mathematically, taking a small segment here of dl length and derived it to find the temperature profile to be linear. So that's all about my interview. 5 questions were asked from me, and 2-3 subjects were asked only. Questions from only 2-3 subjects were asked, and my final result came on yesterday, that is 12 June 2022, and I got selected in that. So that's all about my interview. We'll make video on interview experience of other PSUs also, like I gave interview of NPCIL, EIL, and GATE. We'll make video on them soon, so subscribe to my channel. Thanks.